So we are going to define a domain, and a domain is a set of values is a set of all input values for which the outputs can be determined. For example, if we have a function fx equals to y is our dependent variable and x is our independent variable. This is to mean that x is the input value or values and y is the output. Therefore, if we define a domain using this function, this will be all set of values of x for which y can be determined. Let's have an example. If we have f of x is equals to 1 over x squared minus 1, the only time in which f of x, which is also equal to y, cannot be determined is when our denominator is equal to 0. Therefore, if x squared minus 1, which is our denominator, is equals to 0, we cannot determine the domain. This is the only time we will not be able to determine the this is the only time we will not be able to determine our y, when x squared minus 1 is equals to 0. And this therefore means when x is equals to -1 or 1, we cannot determine the value of y. Therefore, the only exception when we cannot determine y is when our denominator in this case is equals to 0. Therefore, in all other cases, if x squared minus 1 is greater than 0, this will say we can be able to find the domain of this function. Let's have another function. Our other function, f of x, is equals to 1 over x. Okay, so therefore the only time we cannot find the value of f of x, which is equals to y, is when our x is equals to 0. Therefore, the domain of this function is any number except when x is equals to 0. That is correct. And in our first equation, this equation, the domain of this function is any number except when x squared minus 1 is equals to 0, except when the denominator is equals to 0.